tensile stress. Again, the tensile happens above, for this case, above the neutral axis. And where is the maximum tensile? Everything, every point on the top. Which means we choose the location where it gives us the largest value of y. So under these situations, I would rather not to directly apply this formula. This formula combined with the sign. This formula, if you choose your y correctly, y is a coordinate that could be positive, could be negative, and then you combine it with the sign. The whole thing will give you the magnitude as well as attribute of the stress. And here I would rather not to do that way. And the sign will be directly told by this, which means by our observation first. And then for the remaining, I will only focusing on the calculating the magnitude, only using this number here. Okay, so here the n is how much? 3.3 kilonewton. And y is the distance from the neutral axis to the top, and that will be 22. And everything will convert it into the Newton meter unit. And I is 868 times 10 to the minus 9. So this one, already we know that is tensile, and this one we simply work on the magnitude. And again, here, this is a y. The y is representing the distance from between the neutral axis and the point. So in this way, we only measure the distance. We don't care about the sign. The sign has been taken care of in that graph. And the maximum compressive, and that one, again, the maximum compressive will be at the bottom here. So that will be equal to M 38 and I. Okay. And the curvature will be equal to M over EI, and this one is very straightforward. We simply do the calculation. So the number you simply plug in, the unit will be in radian. Okay, so later I will turn on this slide and you will see the result. And this example is from our textbook, the sample example. Okay, so here for the exercise, my preference is I try not to directly apply this formula. Okay, and I know that some of you came from the different sections, which is not with me last semester. So you might have a question, say, hey, if I insisted I want to use this formula, I don't want to use this approach, then what we can do? Let me try. Okay. So if you like to use this formula directly, then you can do it this. You have to apply the sign convention. And again, either approach you feel comfortable, you pick one. For the sign convention is this. If this will be the beam, and we bend up, curve up, the bending is positive. And for the coordinate system, of course, that is very trivial, x, y. For any point above the x-axis, and that is give us the positive y coordinate. Otherwise, it's negative. So we're using this approach. For that formula, sigma equal to minus. Okay, now if I want to calculate the point here, for example, point A is the point anywhere on the top surface. So the stress at point A will be equal to, right now I apply the formula directly. So for this case, M, for our example, positive or negative? So for example here, this is X, this is Y. For our example, it's negative. So minus 3,000. And what is Y? Y is positive and 22. And divided by I. So from here, negative give us positive. Okay, and then sigma at point B. Point B is at the bottom here, anywhere at the bottom. And so for this case, it is minus. The M is negative. And the coordinate at the B is negative. And divided by I. So here we have 3 negatives, so the come out is negative value. You can see using this formula, if you apply this formula, you have to apply the sign convention carefully. If you miss one, then you miss the sign. But convenient is from here you can see the bending right now, the beam is protruded here. If you try to bend down like this, from your intuition, you can quickly check the upper portion will be in tension. This way will help us to get rid of those kind of bothersome kind of sign. So up to you, either way you prefer, just go stick with what you have exercised. So those are the kind of examples provided to you. And here, this slide onward is the